In this video, we're going to talk about the measures of central tendency. So the mean of our data is the average. So the average of a data set, meaning you got to add them all up and divide by the total number of data points you have. So add up and then divide by the number of data points. Okay. The median is considered the middle value of your data. So the middle value, and you have to list your data from least to greatest first. So list the data from least to greatest. Then you find the middle, and if there are two values in the middle, you have to average those two together to get the median. The mode is the most frequently listed data point. So it's the most frequent, and you can have more than one mode in a data set. That is okay. For measures of spread, we have standard deviation, which is how far your data is spread out around the mean. So it's how far the data is spread out from the mean, which is the average of your data. Q1 is considered the first quartile. Q3 is the third quartile. And IQR is Q3 minus Q1. And the the letters IQR stand for interquartile range, is what that means. That is when you have a box and whisker plot. And so you have a little minimum value over here, and then you have a whisker, and then you have a box. And in the box, you have your median in the middle. And on the edge of the box, you have quartile 1. And on the end of the box, you have quartile 3. And then you have another whisker. And then you have your maximum value. And in a box and whisker plot, it's divided up into 25% of our data falls between the minimum value and the first quartile. And then another 25% of the data falls between the quartile 1 and the median. Another 25% is between the median and quartile 3. And then the remaining 25% is between quartile 3 and the maximum. And so the interquartile range, the IQR, represents how far it is from Q3 to Q1, or the difference between those two, because that gives us our range of our middle 50% of our data, which we're very interested in that when we look at statistics. The minimum is the lowest value in your data. Let me grab my pen. Let's see. That is the lowest value in the data set. So I'm sure you can predict the maximum is the highest value in the data set. And the range is the maximum minus the minimum. That gives you your range. So if you're given the mean is 3 and the standard deviation is 2, I just showed you what a box and whisker plot looks like very briefly. Let's look at what a normal curve would look like in this case, because this is how this applies to our data. If we have a mean of 3 and our data is normally distributed, we would put that right there in the middle of a standard normal curve. And then a standard deviation of 2 means that 2 could be added 3 times above the mean. So 3 plus 2, because 3 is the mean. So 3 plus 2 is 5. And then 5 plus 2 is 7. And then 7 plus 2 is 9. Because our standard deviation was equal to 2, I can add 2 3 times to the mean, and that gives me the upper half of my normal distribution curve. And then on the lower side, I can subtract. So I can subtract 2 from the 3, and I get 1. and then I could subtract 2 more, and I get -1. And then I could subtract 2 more, and I get -3. And just briefly again, what we know about a normal distribution curve is 68% of our data falls in between the first standard deviation from the mean, and then within 2 standard deviations of the mean, we have 95% of our data, which is a lot, as you can see. And then within 3 standard deviations of the mean, we have 99.7% of our data. So that's why it's important when they give you the mean and they give you the standard deviation, is you can easily map out where your data would fall. I can tell that between -3 and 9, 99.7% of my data would fall between -3 and 9. And 68% would fall between 1 and 5. So it's a lot of information they give you when they give you these 2 pieces of information. It allows us to set that up. And then let's look at an example of, given a data set, they want us to find all of these things. And it's actually really easy in your graphing calculator, and it can be easy in Desmos. So in Desmos, you have this functions menu in here, and you can go to statistics, and there's all of these good buttons. But I really think in this case, our graphing calculator is very helpful. So I'm going to show it to you on there. So let's type in our data set in our graphing calculator. So go to stat, I'm going to write this down. Go to stat, and then hit enter, because it's going to let you edit the list 1. That's what we want, to stat, then you want to edit. And under list 1, make sure it's clear. And if it's not clear, go to the top where it says L1 and hit clear, and then down or enter, and it will clear out that column. So let's say clear, and it clears it out for you. And then you can type these numbers, the data set they gave us, 14, 10, 2, and so on. So type those into L1. 14, 10, 2, 13, 16, 3, 12, and 11. And once you get them all typed in, you want to make sure you've typed the right number of numbers. So I got 1, 2, 3, 4, 5, 6, 7, 8. It's good to double check. I got 8 numbers in my calculator. Now you're going to hit these buttons. You're going to go back to hitting stat, but then you're going to go over to where it says calc at the top of your screen. So stat, calc, and then you want the first option, which is 1 variable statistics. It's a very helpful little button. So hit that one, and then hit enter if you need to calculate until it pulls up this screen. And the mean is right there at the top. That is the X bar, and they give that to you as 10.125. The median is down there in the list a little further. It's MED abbreviated, and that is 11.5. The mode is the most frequent. I don't know if they list that in here, but you can just see if there is one that has repeated itself. So let's see. The mode, I don't see a number that got repeated in this data set. So we just have no mode for this data set. The Q1 is 6.5. We can see that over there on the screen. So Q1 is 6.5. Q3 is 13.5. So IQR is always Q3 minus Q1. So 13.5 minus 6.5 is equal to 7. And then your range is your minimum and your maximum, but you want to subtract the maximum, the big number, minus the minimum value. So the maximum was 16 minus the minimum, which was 2. So your range would equal 14. And then last but not least, standard deviation is S sub X. So it's back there toward the top. And that was 5.8. 0.06. Let's just round it off. Okay, so notice everything you can find in your graphing calculator with relative ease. You just got to type in your data, then go to Stat Calc 1 to pull up all of your information. But let me show you the next one in Desmos in case you do want to do it that way, you can. So let's add a table of values. And in the table, we're going to enter our data. So just under X sub 1, we're going to put all of this just in one long list. So 47, 34, 36, 38, 56, 35, 47, and 35. And then count your numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I think I got everything I need. So now notice it's under X sub 1. So you just need to put that in Desmos. You want to type in the mean and tell it mean of X sub 1 because that's what you need the mean of. So I'm going to go to functions and I'm going to go down to statistics and I'm going to put mean, and then it's asking me what do I want the mean of, and I have to type that in there. So that would be 41.4 repeating. And then I want the median. Ooh, I'll just leave that there. So let's find the median now. So go to functions and statistics and put median X sub 1, and that gives me 38. So the median of X sub 1 is 38. The mode, let's see if they have a mode button. They do not. So we can look and see, are any of these repeated? So I do see 47 is listed twice. And 35 is listed twice. And then I think that's it. So we actually have two modes. We have 47 as a mode, but 35 would also be a mode. And you just list whichever ones they are. And if one was listed more than the other, you only need to list that as your mode. So Q1, let's see. Did they give us an option? There it is. So quartile for X sub 1. Let's see what happens. Let's see. This one says quartile 2 arguments. For example, try typing quartile 1, 2, 3, comma 1. So it didn't like it when I did it that way. But I can show you by hand how to find the quartiles for this data. So let's actually work something out here. We're going to list them from smallest to largest first. So looks like 34 is the smallest. Then we had two 35s. Okay. Then we have 36. Then 38. 45. Two 47s. And 56. Okay. So again, I had 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you want to start marking off until you figure out what the median is, which should be 38. We already know that. But just to show you an example, I can mark off the largest and the smallest, and then the second largest and second smallest, until I work my way to the middle, which we've already determined the median was 38. Quartile 1 is the median of the first half of your data. So it's the, let's add that over here to our vocabulary. The first quartile is the median of the first half of the data. And quartile 3 will similarly be the median of the second half of the data. Okay, So quartile 1, the median of the first half, that's why it's called quartile 1. And then the third quartile is the median of the second half. So now that we've got everything in order and we found the median, we just have to do it again and figure out the median of the first half. So you want to mark out the first and the last, but then you got to average these two together. So we can see that 35 plus 35 divided by 2 would just be 35. So that's quartile 1. Then quartile 3 would be to mark out the first and the last and then average these two together, which notice if I average those two together, that is just still going to give me 47. Okay, then interquartile range is to just take Q3 minus Q1. So 47 minus 35 leaves me with 12. And last but not least, the range. So I've already got the minimum value and the maximum value. Kind of messy, but I can still see that the minimum is 34 and the maximum was 56. So I just need to say 56 minus 34 is 22. So the range of my data was 22. And then standard deviation, we can probably come back over here and use Desmos again. So standard deviation is STDEV, is how they abbreviate it. That's what they mean. And then I just got to tell it that I want the standard deviation of X sub 1, which is 7.63. Okay. So your calculator is really helpful, but you can also find all of these by hand. But obviously it helps to save some time to use your technology when you can. So that's it for these notes on measures of central